All right, hello. So this is the section 11.1 video. And so we're going to be talking a little bit about the number E and how it pertains to compound continuous interest. So first off, the number E is defined as the limit as n goes to infinity of the function 1 plus 1 over n all to the nth power. And so this formulation of what E is might seem a little awkward at first, but it has this very nice and neat property that allows it to be used in what's called the exponential function. And we'll kind of talk about that here in the next couple of slides. But it's good to just note that this is what it is, and what it comes out to actually be as a constant is 2.718, and then there's a bunch more digits that it continues on with, but you don't need to worry about too much more than just this amount that you see right here, mainly because if you try to do any calculations, that's about as many significant figures as you'll need. And so this is how we define E. You can also define it by taking the limit as s goes to 0 of 1 plus s to the 1 over s power, or if you'd like to call it the s root. And that's another way that you can get to this particular value of E. Either of them will work, either with the n or the s, but they both come out to the same value. Now, when we're looking at compound continuous interest, we use what is called the exponential function, and that is this amount right here that you'll see, this e to the RT. So this exponential function gets multiplied by the principal to find what our end result or the account value at the end of the investment would be. And this exponential function is basically this E constant that we found to the power of R, which is our interest rate, times T, which is our time. And so the interest rate, which is usually given in percent per year or an APR or of some sort, is going to be multiplied by our time, which is usually in years, to give that exponent of our exponential. And you can calculate out what the account value would be given the principal, or you can reverse some of this in order to find the interest rate or the time given 3 of the other variables in this particular equation. And so with any particular version, you're going to need to do some operations in order to solve for one of the variables. So we need to know how to undo an exponential function. So in order to undo an exponential function, we need to know what the inverse of that exponential function is. And here we have what the inverse of that exponential function is, defined as the natural log function. And so we can take a look at kind of what this is. So if we had an exponential of e to some alpha, then it would be equal to some beta value, just as an assumption of what the exponential would be. We can then say that the inverse would be this natural log of b, which is equal to alpha. And so this is sort of taking the approach that we're saying that this is the function that's going to be the inverse of this exponential. And we can basically say that this is true because anytime that you're looking at the natural log function, the way that it works out is it's basically looking at whatever the e exponent would have been for a particular value if we were trying to set it to this e to some alpha. And so this is sort of how you can think of the inverse of the exponential function, which is the natural log function. And if we're going to try and solve for either the rate or the time, you'll see that there are some natural log functions which are coming up, being used to sort of transition from solving from either the principal or the final amount. And so these are all of the potential ways that you can rearrange the compound continuous interest formula to come out to an equation which can solve for one of the four variables in it. So we have our final value, which we can solve for, which is just the initial compound continuous interest formula, just rewritten out. We can also solve for the initial investment. So if we know what the final value we want is, and we already have the rate, we have the time, such as a CD, for example, which is usually a set time and it's usually a set rate for its final amortization or for its final maturity to reach a certain point. Then we would figure out what the initial investment would have to be for that CD or that financial investment in order to reach that final amount. We can also rephrase it in terms of just positive exponent if we wanted to move that e to the negative RT into the denominator for this previous formula. Both of these are the same formula, it's just slightly rewritten. They would both work if you had the A, the R, and the T in order to solve for the P. So that's how you can solve for an initial investment if you already have an idea of a CD that you're looking at investing in and looking at using that. If you're interested in what rate you would need in order to reach a certain final amount over a certain period of time with an initial investment, then these are the formulas that you would use. This would be if you were looking for a particular return on investment for a particular type of business venture. So say you know that you have a guaranteed CD rate of like 1% per year for an increase, and you know that you have that rate available to you. But say you were interested in starting a business venture and you wanted to get more than 1% for your increase in year-over-year earnings. Then what you could do is you could talk to someone who has potential business interest to invest in, and they could give you their timetable for their amortization or their eventual business profit and how much you would get back from that, which would be your A and sort of your T. And you can look at how much they're asking for you to invest in order to get out that initial amount. And that would be everything you would need in order to calculate what your rate would be for that particular time period for your initial investment and your return, and then the time that you had it. You can calculate that R. And if that R value was greater than the amount that you wanted, in the case that we're talking about, that 1% for the CD, then you would probably rather go with the business venture, since you already have this guarantee that this person or this individual has this business idea that'll work out to a greater than 1% return on investment over the particular time that you're looking at. Then it's probably a good idea to go ahead and go for it from a business standpoint or from a financial standpoint. So that's one thing that you can use to sort of analyze something that you might be going into in terms of calculating rates. If you're interested in calculating for the time, such as if you're putting some money into a savings account, then figuring out how much time it would take for that savings account to reach a certain value, this would be the calculations that you would use here, because usually you have, you know how much is going to be in your savings account, you know what the rate for the savings account is going to be, and you know roughly where you want it to go to. So you can figure out from the time period that you've put it in there, how far it can get up to, or how long it'll take to reach up there, up to the point that you're looking at. So that's what the formula would be here, if you were interested in looking at that. And for both the rate and the time, we're able to rephrase these equations with a slight modification to the natural log function. We can do this because of log properties. And so we can talk a little bit about log properties in another video. But if you're able to use the log and you have a log of a over p, it can come out as log of a minus log of p. And so for these natural logs, we can do this operation to sort of create another equation, which looks slightly different, but still does the same thing. Both of these would come out to the same value, but they are two different ways you can actually do the calculations. So that's a little bit of natural logs and how it applies to compound continuous interest and different ways that you can write the formula for different values that you're looking for. So, all right. I hope that that was pretty informative for you guys, and I'll go ahead and get the next video ready for you. All right. Talk to you soon.